Okay, so let's talk about electric cars. I mean, they're everywhere now, right? And they're all about this promise of a super clean, green future. But is that really the whole story? It's a massive question. And you know what? The real answer is probably not what you think.
So what's the deal? Are EVs our climate heroes, or is this whole thing kind of a carbon lie? Well, to figure that out, we've got to look way beyond that silent tailpipe. I'm talking about the entire story, right from the mine all the way to the scrapyard. That's the only way to get the real picture. And here's the thing. The key to cracking this whole mystery is a special tool called a life cycle assessment, or LCA for short. Think of it like a complete, top-to-bottom environmental physical for a car. It's really the only way we can do a true apples-to-apples comparison and find out which one actually comes out on top. So this LCA breaks the whole shebang down into three main stages. First up, you've got production. That's everything from digging the metals out of the ground to the car rolling off the assembly line. Then there's the use phase. Pretty simple, that's all the miles you drive. And finally, you have recycling. What actually happens when the car's life is over? All right, let's dive into that first stage, production. And this is where the story gets, well, really interesting. Because believe it or not, the moment an EV is created, it's already starting from behind. It's already in a bit of an environmental hole. Yet here's the kicker. The biggest single environmental punch for an electric car doesn't happen on the road. It happens back in the factory. And it's all about one thing, that giant battery. Building one of these things is just a massive energy hog. And check this out. Making that battery can account for a staggering 40% of an EV's total lifetime carbon emissions. Let that sink in. That is a massive environmental debt to pay off before you even drive it off the lot. The best way to think about it is like a carbon down payment. The EV starts its life with this huge environmental mortgage, deep in the red. A regular gas car, on the other hand, starts with a much smaller one. So the race is officially on. Can the EV ever actually catch up and pay off that debt? And that, of course, brings us to the second phase, driving on the open road. Now, this is where the EV starts to fight back. This is where it starts to chip away at that carbon debt, one silent mile at a time. See, here's the deal. Electric motors are just incredibly efficient. We're talking like they turn about 90% of their energy into actual movement. A gas engine? Piff. It's more like a leaky bucket, wasting a huge chunk of its energy as heat. So this insane efficiency is the EV's secret weapon. It's how it starts to pay everything back. The big question, though, is how long does that take? When does it finally break even? Well, in a place like Europe, which has a pretty green power grid, the answer is shockingly fast. On average, you only need to drive around 17,000 kilometers. For most people, that's just a year, maybe 2 years of driving. And after that point, the debt is paid. Everything from then on is a climate win. But, and this is a huge but, it all depends on where you plug in your car. It's all about where that electricity comes from. In the EU, with lots of clean energy, the EV is an absolute slam dunk. But if you're in a country that relies heavily on, say, coal power, that payback period gets way, way longer. This whole idea is called well-to-wheel emissions. It's not just about the car, it's about the power plant too. The simple rule is, the cleaner the grid, the cleaner the EV. And when you zoom out and look at the entire life cycle, the difference is just, it's wild. In Europe, an EV is responsible for about 63 grams of CO2 for every kilometer driven. A gas car? Try 235. That is not even a close fight. It's a 73% difference, a total knockout. Okay, so on carbon emissions, it's a clear win for the EV. Case closed, right? Well, not so fast. The story isn't quite over. There's another kind of sneaky type of pollution we have to look at, and it's called non-exhaust emissions. And this is where things get a little more complicated. Since there's no tailpipe spewing out fumes, the pollution story moves from the engine to the road itself. We're talking about all the tiny, nasty particles that get worn off of your tires and your brakes. And in this fight, the EV has a weird trade-off. On one hand, it's heavier, and that means more tire wear. But it has a secret weapon, a little magic trick called regenerative braking. You can see that trade-off perfectly right here. Yeah, the EV's extra weight creates a bit more tire dust, but look over at the brake dust. It's almost nothing. That's the power of regenerative braking. The car uses its own electric motor to slow down, which means the regular brakes barely have to do any work. They basically get to take a vacation. So there it is, a straight-up swap. Less brake dust, but more tire wear. So the big question is, what's the net result? Which one actually comes out cleaner? Well, here's the bottom line. That regenerative braking thing, it cuts brake dust by a mind-blowing 83%. And it turns out, If you do just a little bit of city driving, like 15% of your total miles, that huge reduction in brake dust more than cancels out the extra tire wear. So the verdict is in, even here, the EV is still the cleaner car.
Okay, on to the final piece of the puzzle. What happens at the end of the car's life? Recycling. And this, my friends, is where the EV's environmental case gets another huge boost. It's a part of the story that, honestly, most people totally overlook.
See, for a normal gas-powered car, the end of the road is, well, it's pretty much the end. It gets crushed and scrapped from metal, and that's about it. But for an electric vehicle, the end of its time on the road is really just the beginning of a new chapter, because that battery, packed with all sorts of valuable metals, is way too precious to just end up in a landfill. Instead, that battery gets to go on a whole new adventure. After its first life powering the car, it can be taken out and repurposed for a second life. A lot of times, they'll bundle these old batteries together to create big energy storage systems for the power grid, and then, only after that life is over, do they get fully recycled to pull out all those precious metals to be used all over again. This is exactly what people talk about when they say circular economy. It's happening right now. We can already recover up to 95% of the critical materials inside, the cobalt, the nickel, the lithium, and use them to make brand new batteries. Now, the big challenge, of course, is building enough recycling plants to handle the absolute flood of batteries that are coming. But if we get this right, it means way less mining and a fundamentally greener way of building things.
So when you take a step back and look at the entire picture, from the mine to the road to the recycling plant, the conclusion is pretty darn clear. The debate really shouldn't be if EVs are cleaner. They just are. The real question, the much bigger and more important question, is this. How fast can we clean up everything else around them? How fast can we make our power grids green and our supply chain sustainable to truly unlock their full world-changing potential?